In our last video, we introduced the concept of Arrhenius acids and bases. So those are great definitions, but we're going to talk about a different definition for our acids and bases now. This one was created by these two guys on the left. We have Bronsted and Lowry, and you can see when they lived, these two guys worked together to come up with this definition for a Bronsted-Lowry acid and a Bronsted-Lowry base. So they have said that a Bronsted-Lowry acid is a molecule or ion that is a proton acceptor. So you may notice some similarities between this and Arrhenius, and that's fine, but theirs is just a little more distinct. So notice we still have that HCl reacting with water to form the hydronium and the chlorine that we saw previously. Notice that in this case, that HCl, it is donating a proton, that H+, to water, so we can consider HCl as a Bronsted-Lowry acid. So it's still a Arrhenius acid, but it is also a Bronsted-Lowry acid by this definition. For a Bronsted-Lowry base, they've said that it is a molecule or ion that is a proton acceptor. So again, let's look at that same chemical reaction. We have HCl plus H2O react to form that hydronium and that chlorine ion. Notice here that H2O, that water, it is accepting that proton that the HCl gave away. So by this definition, water in this instance is a Bronsted-Lowry base. Now we typically say water is neutral, but according to Bronsted-Lowry's definitions, it can act as a base. So make a note of that, it can be a base. And then I'm going to show you something. We have another reaction here. We have water, again, reacting with NH3 to form NH4 plus and OH minus. So notice what happened here. Water gave away one of its protons, one of its hydrogen ions, to create something that is positive. So it donated a proton to this guy right here to form NH4 plus and then OH minus. So in this case, water has donated a proton to NH3. So by this definition, water is a Bronsted-Lowry acid. So again, notice water is typically neutral, but it can react as either a Bronsted-Lowry acid or a Bronsted-Lowry base. So it doesn't have to be the same definition as Arrhenius. Arrhenius would not consider this the same thing, but it works in this case for Bronsted-Lowry's definition.